Hi, this is Wendy Lightheart, and today we're going to learn how to graph some quadratic equations. Remember that when we were graphing lines, that was a graph that we got from a linear equation. The graph of any quadratic equation in x and y is a parabola. Parabolas are shaped either like bowls or like inverted bowls. Consider the quadratic equation y equals ax squared plus bx plus c. If a is positive, then the parabola opens upward like a bowl. And if a is negative, the parabola opens downward like an inverted bowl. Whether the parabola opens upward or downward depends on the coefficient a of the leading term of the quadratic. The a is going to be the coefficient on the x squared term, so no matter what order those terms are in, look for the coefficient on the x squared. Now these parabolas have a special point called the vertex. If a is negative, like the graph on the left, and it's opening downward, then the vertex will be the very highest point on the graph, on that parabola. If a is positive, like the one on the right, so it would be opening upward, then the vertex will be the very lowest point on the parabola. So let's look at some steps for graphing quadratic equations. So the steps for graphing quadratic equations of the form y equals ax squared plus bx plus c starts with the step where you want to determine whether the parabola opens upward or downward. So look for the coefficient on the x squared, and if that is a positive number, then the parabola opens upward, and if it's a negative number, then you know it's going to be opening downward. And this is really good to do as your first step, so when you start plotting points, if it doesn't look like it's opening upward or downward like it's supposed to, then you know you're doing something wrong. The second step is to find any x-intercepts. Now when we were graphing lines, remember that the x-intercepts were the points on the line where the y-coordinate was 0. And that's because every point on the x-axis has a y-coordinate of 0. So we do the same thing when we're graphing quadratic equations. We find x-intercepts by replacing y with 0, and that will result in a quadratic equation, so we solve that quadratic equation for x. And I should note here that if there is only one x-intercept, then that is going to be the vertex of that parabola. The third step is to find the y-intercept. And just like when we were graphing lines, the y-intercept is where the x is 0. So we replace the x with 0, and then we simplify that to know what y is. The fourth step is to find additional points by plugging in several values for x and finding each corresponding y's, and that will give us a collection of ordered pairs, and we can plot those ordered pairs as points on our graph. And then note that the vertex can be found by finding the average of the two x-intercepts and plugging in that value for x. So sometimes you will be given the values to plug in for x, and so they'll give you the value of x that's going to give you the vertex, but if they don't give you values to plug in, that's how you can find the vertex, or the x-coordinate of the vertex, is by averaging the two x-intercepts and then plug that value in for x, and that will give you the y-coordinate. The fifth step is to plot the intercepts and the additional points that you found, and then connect with a smooth curve and place arrowheads at each end to finish off your parabola. So let's graph an example. We're going to graph the equation y equals x squared minus 9. So the first step is to determine whether the parabola opens upward or downward. Now notice that the a in this case, the coefficient on the x squared, is 1. That's a positive number, so we know that it's going to open upward. Find any x-intercepts by replacing y with 0. And then we solve that resulting quadratic equation for x. So we replace the y with 0, and that gives us this quadratic equation, 0 equals x squared minus 9. Now remember that we solve quadratic equations by factoring. So if we factor this, it's a difference of squares, so it will factor into x plus 3 and x minus 3. And the solutions then are negative 3 and positive 3. So our x-intercepts are the points negative 3, 0 and positive 3, 0. The third step is to find the y-intercept by replacing the x with 0. So we replace the x with 0, and we square the 0, and that is 0. 0 minus 9 is equal to negative 9. So the y-intercept is the point 0, negative 9. Next, we need to find additional points, including the vertex. So remember, the vertex can be found by finding the average of the two x-intercepts, which remember were negative 3 and positive 3 for this example. So averaging them means we add them together and divide by 2. Well, negative 3 plus 3 is 0, and 0 divided by 2 is 0. So our vertex has an x-coordinate of 0. Well, we already found above that when x equals 0, y is equal to negative 9. So it just so happens that our vertex is the same point as our y-intercept we already found of 0, negative 9. Now we're going to find some additional points by plugging in a few values for x. So the values that we're going to plug in are negative 2, negative 1, positive 1, and 2. So we start by plugging in negative 2 for x, and when we square negative 2, that's equal to positive 4, and positive 4 minus 9 is equal to negative 5. So when x is negative 2, y is negative 5. That gives us an ordered pair, which gives us the point negative 2, negative 5. Now we can plug in negative 1 for x, and when we square negative 1, we get positive 1, and 1 minus 9 is equal to negative 8. So that tells us that when x is negative 1, y is negative 8, and that x and y together gives us the ordered pair negative 1, negative 8. Next, we'll plug in positive 1 for x. We square positive 1 and we get positive 1. Subtract 9 from that and we get negative 8. So when x is equal to positive 1, y is equal to negative 8, which gives us the ordered pair 1, negative 8. Now we plug in positive 2 for x, and when we square positive 2, we get positive 4, and 4 minus 9 is negative 5. So when x is positive 2, y is negative 5. So that gives us the ordered pair 2, negative 5. Our fifth step is to plot all these points that we found, including the intercept and those additional points. And then we're going to connect with a smooth curve and place arrowheads at each end. So the first 2 points that we found, remember, were the x-intercepts, negative 3, 0 and positive 3, 0. So you can see those plotted on the graph. The next point we found was the y-intercept, the point 0, negative 9. And remember, that's going to be our vertex, so when you look at this, you should be able to start seeing the parabola take form. Next, we plot the other 4 points we just found, negative 2, negative 5, negative 1, negative 8, positive 1, negative 8, and positive 2, negative 5. Now we can connect these points with a smooth curve and put arrowheads on the end, and we're done. There's our parabola. So we'll do several more examples in class, and just remember to go through these 5 steps. And when you're solving the quadratic equation you get when you find the x-intercepts and plug in y for 0, just remember that you're solving those equations by factoring. So go through those usual steps for factoring and you'll do fine. We'll see you then. Bye-bye.